What we're going to talk about today is the list interface. This is the testable interface for the AP exam, but it also is a really good introduction to a big picture idea called polymorphism. Before we get to that, there's one thing I wanted to mention, which I don't know if Dr. Perulli emphasized enough. An interface is essentially like a behavior contract. What it tells you as a programmer is if you're using a class that implements a certain interface, you can count on those functions being defined that appear in the interface. So it's a nice way to kind of set up a larger class structure. Now, at this point, we've only talked about single classes, but in the next topic, we're going to start talking about building sets of related classes. And so that's where this is all going to kind of come together. So if you're not sure you totally understand why you'd use an interface yet, just hold on and we'll get to a point where that's a lot more comfortable for you. One way I can try and explain it is this idea of polymorphism, which is a big idea in object-oriented programming. Polymorphism just means many forms. That's what the Greek root is for it. And essentially what it tells you is if you have a reference to something like a list, you can store in that reference variable any type of object that implements that list. So that's really helpful for us because we can, inside a list variable, we can actually store array lists or stacks or vectors or anything that implements the list, which is pretty great. And that flexibility in terms of your choice of data structures is why at this point you may want to consider using the list reference, specifically the list interface. As I mentioned earlier, this is the testable interface for the AP exam. Now what that means is you should know the functions that are that appear in the API for it, and you should know a little bit about how it's used, like that it can store things that implement the list interface. Okay. The methods that you are responsible for include the 5 that show up on your screen now. So size, add, get, set, and remove. And so they're pretty straightforward. There are 2 versions of add, but other than that, I think they're pretty easy to understand. When you take the AP exam, you actually get a sheet which contains, it might be multiple sheets, but it contains the testable API, meaning these are the functions that they will use in the in the questions that they expect you to know how to use. And it's useful to look at them before you go into the test. Even though you have this reference and it'll appear just like what you see on the screen, you'll want to know these well enough that you don't really have to go back and look and spend a lot of time trying to figure out how to use them. Okay? It's a lot easier to go in with that knowledge and then have it as a safety blanket in case you have one of those sort of stressful moments in a test and you can't think straight. So let's kind of walk through these methods briefly. First of all, size, which as you expect just tells you how many elements are in the list. There are 2 add functions. One, the Boolean one, which just adds an item in the very last spot in the list. Basically creates a new spot in the list and adds it on. It returns true in most cases. I'm not sure in what circumstance it would return false. We'd have to look that up, but that's not anything I think they'd ever test you on. There is an add method that doesn't return anything, that allows you to add anywhere within your list. And the nice thing about that is it actually shifts everything over to the right and then puts your element in the spot that you specify by the index. Notice that both those functions specify the data type that's being passed to it as E. I think Dr. Perulli mentioned this. That's what we call generic, meaning that E will be a very specific type, but that type will be specified when the list is created. So it doesn't give you carte blanche. You can't just put anything you want in there, meaning like it can't be an integer one moment and a string the next moment. But what it means is it's kind of a way that you can define methods that will have a kind of a plurality of type when you're actually implementing it. Okay. Next we have the get method, which just returns the value, just like your getters and setters that you learned about when you learned about classes. The set method is great because it really allows you to overwrite data, and what I like about it best is that it actually returns the old value. So that way if you need that old value, let's say you're like swapping elements on a list as you're sorting things, that actually allows you to get the old value right in one function call, which is really cool. The remove method is almost like the opposite of the add method. in this case, it actually moves everything to the left, and it overwrites the element that you want to remove, and then make sure that it adjusts the size. Okay. The last important detail, I mentioned some other data structures, but you're really only responsible for ArrayList, and ArrayList implements the Java list. Both those are in java.util, so we need to know that for when we import. Okay, let's see this in action, because I think it will make a big difference as to some of the things that I mentioned in the previous slides. What you see here is actually my IntelliJ window. I'm not going to write a whole lot of code here, but I wanted to do some examples using the list interface with a class that we're going to call to-do list. So the way this is going to work, I wanted to kind of demonstrate the polymorphic aspect. So what I'm going to do is I'm going to write a main function. I probably should have done this before I started filming it, but that's okay. In my main function, I'm going to declare a new list. So what I want you to notice there is that it gives me a lot of options for sure. But one of the things you see here is it actually gives me that, what we call a template. So I can actually make a list and declare that it's going to hold strings. Also note above that once I type that, it wants me to import the proper library. And if you hit Alt-Enter, it'll actually do that for you. Notice that I just put that right at the top of the page for me, which is really helpful. My list is going to be called, oh, I don't know, how about my list? I'm not feeling very creative today. Now, I'm going to do something that's incorrect here. You can't declare a new list. Oops. And it yells at you right off the bat. And that's because list is what we think of as an abstract type. It's an interface, meaning that you can't actually instantiate a new version of list because there's no state, there are no variables, and in fact, if you remember from some of the other interfaces that you looked at, there are no definitions to the functions. So it makes no sense to make a new list. What we're going to do instead is we're going to actually change this and make your first advanced data type, which is an array list, which Dr. Pruli is going to talk about in the next section. Once again, notice that it's telling me I need to import that, so I'll do that. But see, the thing that we really wanted you to see here is that you can actually store this array list inside a list reference. And what you know when you use my list, which is of type list, it's not of type array list, it's of type list, is that it will have access to certain functions. So when I use that dot operator, I can go look at which functions belong to it, and there are more than what we talked about, but the ones that I'm guaranteed are things like get. So I could get, the 0th item in the list. Now if I was to run this code, this would actually introduce an error into the program because we haven't put anything in our list. We would instead want to do steps like this first, where we'd say add the element, let's add the number 5, we'll repeat that, add the number 10, so on and so forth. And that allows me to call the methods of list that were in the interface. Now let's make sure we understand the other methods that we have access to, things like get. Now in this case I can only get the items 0 and 1, right? So I'll get item 0 and I'll store that inside a variable. Actually, one thing that I noticed that I did here, I was just thinking this is supposed to be my to-do list. I was putting numbers in there. Let's put some things. Let's fold the laundry. I always got to do that. These are boring domestic tasks that we all have to do once we get older. Let's say cook dinner. That's actually can be quite fun, I think. And what I'll do is I'll store the first task. So we'll say first task, and we'll get that first item. Okay. So remember, get returns a string in this case. This is what we meant by that type. So that's generic. So we said it was going to be string, so it'll return a string. Other types I can do, other methods. I can do remove. So I can remove item 0. And now, if let's just copy that line and paste it down below. I don't want to redeclare first task. But now my new first task is actually going to be to cook dinner, right? And if I ran this program, assuming that I didn't make any other errors, we'll compile it, and let's make sure we run it over here. It should print out cooked dinner. There we go, cooked dinner. Okay. Now, I'm going to show you something that I'm hoping that my TAs have talked to you a little bit about, which is how to debug something. So I'm going to put, this is called a breakpoint, and this breakpoint is actually going to allow me, when I use the debugger, which is this bug button over here, it's going to actually allow me to see what's going on in my program at that specific spot. So I'm stopped here at this line, and if I expand down here, you'll see my variables are all listed, so you can see the current state of the program. And I open it up, and it actually has fold laundry and cook dinner as the 0 and first element. Now there's a bunch of buttons up here that you need to know how to use. One is called step over. That means execute the step without looking at the code that lies beneath it. So if I don't want to look at what happens inside the add function, I can step over it. I could also step into it, which means go look and see what the execution is at the function below this, and then there's the step out. So if you're ever done looking inside, you can actually automatically jump out. So these are really handy. Now, of course, you can also press play, and you can use some of these other buttons and explore those on your own. We're going to use the step over. So when I step over this line, it doesn't mean don't execute. It just means don't show me all the underlying details. And you can see that it actually inserted Watch Netflix in between fold laundry and cook dinner. And we can keep walking through here. If I now remove 0, which is the next one, you notice that it actually removes that first one. And now it's going to store in first task the 0th element, which is watch Netflix. And then it's going to use the set function, which is actually going to store go for a run in 0, and then return watch Netflix. And then it prints those out. And now we're done. So that's actually a pretty cool way to do it. You can put as many of these breakpoints as you want, but you have to set them first, and that's how you can debug.